So hello, today we are going to discuss about the impulse response of a first order RC circuit. So this is a impulse voltage applied in the input, and we have to tell like what will be the waveform of the output voltage. Okay, so here the impulse is applied at t is equal to 0 second. So at t is equal to 0 second, when we applied the impulse signal, so here the frequency tends to infinite, and as we know, the capacitive reactance is inversely proportional with the frequency. Then capacitor will act as a short circuit, so total voltage will drop across the resistor. So this phi del t amount of voltage will directly applied across the resistor. So the resistor will generate a current. So how much of current it will generate? Phi del t by R. And if you remember, we also have a property, like capacitor have a property, like if capacitor get an impulse of current, then it can charge instantaneously. So in this case is getting impulse of current, so the capacitor will charge instantaneously. So what is the equation of the current in the capacitor? IC is equal to C dVc by dt. So Vc is nothing but 1 by C minus infinity to t integration of IC t dt. So here ICT is nothing but the impulse current. So it becomes phi by R del t dt. So it becomes phi by RC. So phi by tau. So initially at t is equal to 0 plus only, the voltage across the capacitor becomes phi by tau. Then after that there is no existence of the input, because the input is only exist at t is equal to 0. Then there is no input, there is 0 input. So the circuit will look like this. This is ground, this is resistor, and this is the capacitor, which charge with the voltage phi by tau. So what the capacitor will do now? So capacitor will gradually discharge through this resistor, and eventually the voltage across the capacitor becomes 0. So the output response will look like this, where the time constant will simply be RC. I hope you understand this. So this will be the response in the output. Okay. So now let's discuss another similar type of question. Here also we have to find the voltage across the resistor. So it acts like a simple high pass filter. So at t is equal to 0 plus, what happened? Omega tends to infinite and capacitor acts as a short circuit. So total voltage will appear across the resistor. So initially this high amount of voltage, like phi del t impulse of voltage, will appear across the resistor. So then what happened? The resistor will generate a current. So what is the value of current here? Phi by R del t. So this current will charge the capacitor instantaneously, as this is a impulse of current. So suppose this is the polarity of the voltage of the capacitor. Now what will be the voltage of the capacitor? 1 by C minus infinity to t integration of ICT dt. So 1 by C minus infinity to t phi by r del t dt. So it will be phi by rc, so phi by tau. So the capacitor voltage will be phi by tau amount, but here the output voltage will be in opposite direction, so it will be minus phi by tau. So after t is equal to 0 there is no input, so our circuit is basically look like this. Here the voltage is phi by tau and here resistor is present. So eventually what happened, this capacitor discharge through the resistor and gradually its value becomes 0. So this is the output waveform. Today I am only discussing about the time response. Later I will discuss the frequency response also. So I hope you understand the process. So first what happened, when we apply the impulse voltage input, the total voltage will apply across the resistor and resistor generate the current which create a instantaneous voltage in the capacitor, and when there is no input the capacitor will discharge through the resistor and eventually the output becomes 0, and the time constant of this circuit is RC. Now let's discuss another circuit. Okay, so in this circuit also you have to tell like what will be the output. So at t is equal to 0 plus omega tends to infinite and both the capacitor acts as a short circuit. So equivalent circuit will look like this. This is the input phi del t C, this is 2C. So can you tell like what will be the voltage across this capacitor? So it will be phi del t into 2C by 3C. So it will be 2/3 of phi del t, and here remaining 1/3 will present. So this voltage will also appear across the resistor. So for this reason what happened, current start flowing through the resistor. So what will be the value of the current here? The value of the current here 2/3R phi del t, and here current will be 1/3R phi del t. So we also have to find like what is current flowing through the capacitor, then only we can tell what will be the output voltage. Now from this we can predict that as impulse of voltage is applied which generate impulse of current, so capacitor will charge instantaneously to some value, then when impulse is removed the capacitor will discharge through the resistors. Okay, so now here the amount of current is flowing 1/3R phi del t, and here amount of current flowing is 2/3R del t. So what is the remaining current? 1/3R phi del t. So this amount of current is divided across these two capacitor. So if we apply current divider rule, so we can easily find that what is the amount of current that is flowing through this capacitor. So it will be 1/3R phi del t into 2C by 3C. So it will be 2/9R phi del t. So now as we know the current, now we can easily find out the voltage. So what will be the voltage? VCT it will be 1 by 2c integration of minus phi to t 2 by 3r phi of del t. So it will be sorry 3r, and again another 3 is present, so 3 into 3. So here the value of the voltage is, this 2 will be cancel out, so value of the voltage will be phi by 9rc. So this is the amount of voltage that will be created across this capacitor. So initially this 2/3 of phi rt, sorry, phi del t impulse of voltage is present across the capacitor, then it will change to phi 9rc, then it will gradually discharges and eventually becomes 0. Okay, so this is all. So I will discuss the frequency response part of this later. So thank you.